Hello everyone, this video tutorial is related to performing the analysis through Smart Pls. So first of all, you have to save your data file, which is your final data file, into the CSV format because the Smart Pls only support CSV format. So what you have to do is you have to save this file into CSV format. So I'm just saving it, save as type, comma delimited, which is basically .csv format. So you have to select this and then save it. Alright, after this I'm just closing this file. No, so the file is saved into .csv format, you can see in the folder. Okay, after this you have to open your Smart Pls. You have to wait. It's taking a little time, I don't know why. Alright, so after this you have to create a project. Let's suppose I'm just writing ABC. Okay, so you can see that the project is created. Double click to import data file. You have to select your data file. I just saved it in this folder. Select it, open this. Okay, after uploading it, you can see that it becomes in green color. You have to click on this project to draw your model. So I'm just double clicking on it. You can see this kind of an interface. You have to select your variables. So my first variable is entertainment, second is irritation, third is appeal, fourth is attitude, and I have to just select it and drag it over here. So this is my research model. You can change the colors from this palette. So I'm just closing it by clicking on this. Okay, I'm just rotating this to the right and this to the top by right clicking on this. After this I'm just connecting these variables as per your approved research model. So this is my model. Okay, after this I'm just clicking on this select option and renaming all of these variables. This is entertainment, so I'm writing entertainment. I'm just ENT. Okay, this is irritation, so I am writing it irritation. This is appeal, APP, appeal. After this is attitude, so ATT, and this is intention. Okay, so now your research model is ready. When you connect all the variables, so the model becomes in a blue color. After this you have to click on calculate. This is the first step which you have to follow while performing analysis on a Smart Pls. You have to click on Pls Algorithm, then just click on start calculation. Okay, when you perform it, you can see the output window here, I'm just clicking on this window to see the values of the outer loadings. These are the outer loadings, and these outer loadings should be above than 0.7. So the values that are below 0.7, first I have to delete all those values. So first I have to see which is the lowest value. So I can see that 0.560 is the lowest value. So I just click on this, and then I press delete from the keyboard, and then again perform the analysis. Okay, all the values, this 0.678, sometimes you can take the values above than 0.65 as well, but I have 1 2 3 4 5 6 items in entertainment, so I can delete few items from entertainment. So I'm just deleting 0.678. First you have to delete the lowest one, because maybe the other value gets improved after deleting the lowest one. Delete this item as well. Okay, all the values are now above than 0.7, here as well, here as well, here as well, and here as well. After this, you have to click on the output window and see the values of Cronbach alpha, composite reliability, and AVE. By clicking on this option, construct reliability and validity, the value of Cronbach alpha should be above 0.7. The value of composite reliability should be above than 0.7, and AVE should be above than 0.5. Let's suppose if the value of Cronbach alpha is below 0.7, but all the values of composite reliability are above 0.7, then there is no issue at all. You can consider the values by quoting the statement that composite reliability is a better indicator of predicting the reliability of the instrument or the variable. So in this case, the values of Cronbach alpha and composite reliability both are above than 0.7. That's good. After this, you have to click on discriminant validity. This is the Forner-Lacker table. In this table, all the diagonal values should be above than the off diagonal values in the rows and columns. So 0.840 in the row is above, and in the column is also above. 0.830 in the row is above, and in the column is also above. Similarly, 0.823 is also fine in the row and column. This is also greater than the row, greater in the row and the column, and this is also. So it means that the criteria of Forner-Lacker is appropriate or fine. Then you have to click on cross-loadings table. The values of appeal should be greater in its own column. So you can see that 0.883 is greater in this row, 0.835 is greater in this row, and appeal is 0.53. I think so. This is 0.53. Yes, this is also greater in this column. Okay, attitude should be greater in attitude cell, and entertainment should be greater in entertainment cell. Similarly, intention should be greater in entertainment cell. After checking the values, you have to click on heterotrade and monotrade. All the values should be less than 0.9. So you can see that all the values are 0.9. It means that all the values are clear or fine. So now you have and obviously one more thing is that these outer loadings which you see in the pictorial format, you can also see these values in the output window by clicking on outer loading cell. You can see all the values are above 0.7, and that's why it is in green color. Now all the values are fine. You have checked construct reliability and validity, you have checked discriminant validity. Now you have to save this file. So you have to click on export to Excel, click on start export. This is algorithm results, so you have to save this file as algorithm results and save. You have to just wait. Okay, save. After this, you have to click on this pictorial and you have to save this picture as well. So I'm just right click over there and export as image to file. click on JPG, and this is algorithm picture, so I'm writing algo pic. Okay, and just save it. So this is the first step you have to follow while performing analysis on smart PLS. After this, in the next video, I'll tell you the second step of checking the hypothesis by performing bootstrapping. So that's it for, so I'm just clicking on this, and thank you so much.